Hi everyone, we are looking at text and test page 22. This is exercise 1.5. We're going to skip questions 1 to 4, which have something that we're going to meet later on in the course. I'm just not going to get bogged down in it right now. I want to introduce you. Well, sorry, first of all, we're going to be looking at question 6 here and question 8, part 1. And what I want to do is I want to start off by introducing you to something called Pascal's triangle. So Pascal's triangle is this, I suppose, set of numbers arranged in a triangle. The outer numbers are always 1, and the rule is that the inner numbers are formed by adding the 2 outer numbers above them, okay? So the outer number is always 1, and that one's 2 because you add 1 plus 1. The next line, see if you can guess it, it's going to be 1 on the outside. 1 plus 2 is 3. 2 plus 1 is 3. And sorry, the last number is always a 1 on the outside. Okay, see if you can pause the video there and put down the 4th and the 5th lines. Okay, hopefully you did, and you said it's 1 on the outside, 4, 6, 4, 1, and finally 1 on the outside, 5. 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and 1 on the outside. Now, if you are writing this, can I suggest you put this on the inside of your copy, the inside cover, somewhere you can flick to it easily enough, because you'll be looking this up throughout this exercise, and just it's handy to have it somewhere you can look up. We're learning about something called the binomial theorem. Now, binomial is something that looks like x plus 2. It's something that has 2 terms, 1, 2, okay? And the binomial theorem is if you want to raise that to some power. Okay, well, if I raise it to 1, well, first of all, if I raise it to 0, anything to the power of 0 is 1. X plus 2 to the power of 1 is just x plus 2. It doesn't change. X plus 2 squared is square the first. Square the second, I'm going to leave that as 2 squared, and then twice the product, twice x by 2, okay? And another way of looking at that is that's x squared, that's x to the power of 1, and that is x to the power of 0, which is just a 1. Okay, let me write that out a little bit slower. X squared plus 2 times x to the power of 1 times 2 to the power of 1 plus, I'll write down here, 2 squared times x to the power of 0. So look, it goes x to the power of 2, 1, 0. And it goes 2 to the power of 2, 1. And you can think of a 2 to the power of 0 over here. Anything to the power of 0 is 1. So that's, we know that. The binomial theorem says, look at these numbers. 1 comes from here, matches maybe, 1x and 1, 2, great. The next one is 1 times 2 to the 0 times x to the 2 plus 2 times x to the 1, 2 to the 1, and then 1 times 2 to the 2, x to the 0. Okay, so what you have is these numbers from Pascal's triangle, and then your x coefficient goes x squared, x to the 1, x to the 0, and your 2 coefficient goes 2 squared in the opposite direction, 2 squared, 2 to the 1, 2 to the 0. And the binomial theorem says that pattern applies all the way through Pascal's triangle. So if you look at question 6, which says, using Pascal's triangle, write out the coefficients of x plus y to the power of 6. Well, that's about as simple as a binomial theorem question. Yeah. X plus y to the power of 6, you're going to say, well, what are my numbers? That's to the power of 2, so that's for order 2 expansions, which are often written like this. This is order 1, which you don't really need to worry about because you don't need to, if it's the power of 1, you don't change anything. That's order 3, order 4, order 5. So first of all, we need the order 6 coefficients, which are going to be 1, 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6, and then you need a 1. So we know that we're going to have 1, and then our first term in our binomial is x to its highest power 6, multiplied by y the second term to its lowest power, 0. That's the first term. Plus our second term is 6 multiplied by x. So you're descending. That was x to the 6. This is x to the 5 and y to the power of 1. Plus our next coefficient, 15 x to the power of 6, 5, 4, and y to the power of 0, 1, 2, plus 20 x to the power of 6, 5, 4, 3, y to the power of 0, 1, 2, 3, plus 15 is the next term. X to the power of 6, 5, 4, 3, 2, y to the power of 0, 1, 2, 3, 4, and then 6 x to the power of 6, 5, 4, 3, 2, 1, and y to the power of 0, 1, 2, 3, 4, 5. And the last one is 1 x to the power of 0, which is just, that's all 1, multiplied by y to the power of 0, 1, 2, 3, 4, 5, 6. Okay, and if you spot there's symmetry in this as well, if you were to switch x and y around, you still get the same 6 terms, just in a slightly different order. But this is what the binomial theorem says, and it's really handy because it saves us an awful lot of multiplying out brackets for binomials. But that's a good time-saving device to have in your back pocket. It gets a little bit trickier in question 8 part 1 when your two terms aren't as simple as x and y. So your two terms now are a and negative 2b, and don't forget the signs there, okay? So if you want to expand this, you're going to say, well, what are the numbers for an order 4 expansion? They're 1, 4, 6, 4, 1. So I'm going to have 5 terms here. Oh, can you see my fingers? 5 terms. The first one is going to be 1 multiplied by my first term in my binomial is a to the power of 4, my highest power. Okay, if you multiply out a bracket with the 6 on the top, your highest power is going to be 6. Multiply out a bracket with the to the power of 4, your highest power is going to be 4. A to the power of 4 times negative 2b to the power of 0, plus my next number is a 4 times a to the power of 3, negative 2b to the power of 1, plus my next number is going to be a 6, a to the power of 4, 3, 2, negative 2b to the power of 0, 1, 2, plus my next number is going to be a 4, a to the power of 1, negative 2b to the power of 3, and the final one is plus 1 times a to the power of 0, negative 2b to the power of 4. Okay, so that's just like we did above. Just remember to put your terms in brackets like this. It does keep things a little bit tidier. And maybe even here I should have said a cubed, put the cubes outside the brackets just to keep things straight for the next step, which is the calculations. 1 times a to the 4 times that number is just 1, as is any number to the power of 0. Well, that's going to be a to the power of 4 plus 4a cubed times minus 2b to the power of 1. Well, that's minus 2b. Okay, power of 1 doesn't change it. So that's going to be, minus 4 times minus 2 is minus 8. A cubed b. This one, now minus 2b squared is minus 2b by minus 2b makes plus 4b squared. And then you multiply that by 6, you get plus 24. You've got an a squared there and a b squared from this b times b. Next term here is going to be 4a, and that's negative 2b by negative 2b by negative 2b. So a negative by a negative makes positive by another negative. This is going to be a negative number. 2 by 2 by 2 is 8, multiplied by 4 is 32, a to the power of 1, and b by b by b is b cubed. Okay, you don't need to say to the power of 1, actually, you can just leave it. Plus our last one, that number is 1, a to the power of 0 is a 1, minus 2b to the power of 4. Well, that's a negative times a negative, which is positive, times another negative times another negative, which is also positive. So 3, it's positive times positive. So we're going to get a positive answer here. That's all 1. So minus, what do we have? 2 by 2 by 2 by 2. That's 4 by 4. That's 16. B to the power of 4. So that's our answer. A minus 2b to the power of 4 can be expanded according to the binomial theorem this way. Okay, and you can see that even though that's a lot of work, it's a lot more work than trying to multiply out 4 brackets all in one go. Sorry, it's a lot less work. And particularly once you get used to it, this can be done very, very quickly. So I'm just going to ask you now on page 22, questions 5 and questions 8, part 2, please. If you could do those, and I will see you in class tomorrow.